Hello everyone, welcome back to our YouTube channel Electro Study. This is lecture series 3, non-conventional energy sources dealing with thermal energy and hydropower. Come, let's go into the video. Please do like, share, subscribe and comment. In the last video, we have seen about the solar energy. Now in this video, we'll be concentrating about the thermal energy and hydro power, that is water energy. So here, thermal energy, it depends upon the size of molecules, movements of molecules, how heat is being generated, how heat is being absorbed. So all these together forms the thermal energy. Thermal energy generally it differs from object to object. It doesn't remain the same. So when there is, it is literally said that when the object is very hot, then there is more number of molecules, and when there is cool temperature, the molecules are less. So based on the molecule arrangement, also the energy, thermal energy can be determined. So here you can see three methods: convection, conduction, and radiation. This is all based on the particular heat energy of an object. Now, the thermal energy is nothing but the internal energy that is present in any of the objects, which is in a state of thermodynamic equilibrium. So, the temperature or heat of the particular object will be measured at equilibrium. So, whenever you push an object from one end to the other end, there is an energy called as kinetic energy possessed by that particular object, whether it is a free moving particle or whatever object it might be. So when you're moving that particular object, when the kinetic energy is being possessed, there is an energy that is having a temperature across it. So that is nothing but the total energy that a particular molecule is holding in an object, which in turn is termed as thermal energy. So this thermal energy depends on some things, might be three of the things. So here you can see number of molecules. So when there is more number of molecules, when you add heat, and this is how it forms, where the arrangements of the molecules keep differing. And now here the thermal energy, it is depending upon the number of molecules in an object, as I already told. More the number of molecules or lesser the number of molecules, whether it is hot, cold, all those it depends on. And also it depends upon the temperature of the object, so whether it is hot or cold. Even it depends upon the arrangements of the molecule, so what state of matter it is. All these depends upon how the thermal energy is being generated. And particularly, it has three factors like conduction, convection, and radiation. So, what is conduction, convection, and radiation? So, conduction is nothing but heat is getting transferred from one molecule to the another molecule. So, when you're heating a water in a pan, so you can see the molecule inside the water is being heated one or the other, but there is no movement of water. So when a milk is heated, you can see that the milk comes above the vessel, but when you're heating the water, the more number of molecules, the heat is transferred between the molecules, but there is no movement of water. So that is known as conduction. Next is convection. Convection is nothing but it depends upon the liquids or gases. So how the transfer of heat is done by convection using liquids and gases. So there is a cause of mixing of warmer region and the cooler region. So you have warmer region here and cooler region here. Convection is nothing but when there is heat and cold energy put across a liquid or gas material. That is said to be the convection. Next is radiation. It is nothing but radiation itself means there is a transfer of energy which is in terms of electromagnetic waves. So that is known as radiation. So here you can see conduction, convection and radiation, where the energy is transferred by direct contact. It is transferred based on the molecules, and it is transferred based on the electromagnetic radiation. So hope you have understood the different factors, how it is functioning for a thermal energy. Now we'll be seeing about the hydropower. So, generally, the power that is derived from the energy of falling water or a running water, which is very useful, which is used for very useful purposes. So, you can see that in ancient years, this hydropower was used for all irrigation purpose and operations of various mechanical devices such as water mills, sawmills, textile mills, powerhouse, paint making. So there were different kinds of application. Wherein you had hydropower, here you can observe you have a reservoir where the water is stored across the dam, and based on the requirement of water, the pressure tunnel, that is the valve, is open so that it flows through and it is generating power through the running liquid um, across the power plant. So here you can tell that there is a when the water is running across the power station, there is a generation of power, which you will have power is equal to eta, rho, q, g and h. So when there is a small hydro projects, like it might be around 10 megawatts or less than 10 megawatts, there is no artificial reservoirs required. Only when the projects are more than some 100 kilowatts, then reservoir is required, because it is going to generate high amount of electricity with hydropower. So the power will be available. How the power is generated is when the water is falling across the reservoir, from the reservoir to the power station. Okay, so here you can see there is a power generator. Power will be calculated in terms of watts, and this eta is nothing but the dimension of the turbine, which is kilogram per meter cube, and q is nothing but the flow of the water, which is measured in meter cube per second, and g is nothing but the acceleration due to gravity. H is nothing but the height difference between the inlet and the outlet pipe. So this is how an power can be generated from the hydro power plant. Hope you have understood this clearly. Stay tuned for more information. Thank you.